Good morning, everybody. Today is well, when you're watching this, it'll be Friday, February 5th, unless you're getting an early start on it. But just wanted to go through the notes here and try and be as brief as possible. So you, at this point, should have completed 11.5, learning about regular polygons. And if you haven't done that yet, go watch that video, complete the notes and practice, and make sure to submit that. Don't forget to check the answer key on the practice as well. All right, so let's just get right into it, shall we? 11.6 is all about the area of regular polygons. So 11.5 is talking about the interior and exterior angles of polygons. Well, now, like these angles, now we're going to talk about what is the entire area. So how do we fill this shape in, right? But first, just as a recall, what do we know about regular polygons? As I told you in class and in the video, it's kind of a weird word to use. To say regular, because you think regular is just like an ordinary polygon, but it's regular because all sides are congruent and all angles are congruent. Okay, so it's kind of, I think when they say the word regular, it reminds me of when you're a little kid and you have all these shapes that you're playing with, right? Whether it be elementary school or even prior to that, and they're all the same exact shape. There's no like weird angles about them or anything like that, right? You have like pentagons, you have rectangles, you have triangles. You're trying to fit them into the little spots, right? But they all have the same exact identical shape. Well, that's because they're all made to be regular polygons, right? All right, so how do you find the area? How could you find the area of regular polygons? Well, you could divide it into shapes you already know. So for instance, in this first one, you could divide it into a triangle at the top, right? You have this triangle, and then you could also look at the bottom and say, wait a second, I have a base, and then it looks like a trapezoid, right? So one of the things that you can think about is, oh, I have a trapezoid and a triangle. Well, with trapezoid, you'd have to have the height, okay? Well, that height, all right, in the case of a polygon, this height, right, that's called an apothem. And that's the distance right here, the distance from the center, okay, the center of a polygon to any side, not to a vertex. A lot of students will say, oh, here's the apothem, it's right here from the center to the outside. That's not. That is actually the radius. But no, the apothem is where you go straight down from the center to a side, okay? But again, this one, same way. You could have broken it up into two trapezoids. And just multiplied it. You could have broken it up into triangles, okay, and done it that way. But the important piece of information that we need in order to find apothem and to use the actual formula here for the areas to use polygons, the actual formula has apothem in it. So it's important that you understand that definition, right? So the area of a regular polygon, I'm just going to give it to you here. You will need to know it for the test. I'm not going to give it to you for the test until you try to write it down. Then if you get it right or wrong, I'll mark it off and then give it to you then. But the area of a polygon, you multiply the number of sides times how many, basically a triangle, right? And so a couple pieces of information. Remember, a triangle is 1/2 base times height. So that's why I mentioned, oh, you could think of this as triangles. Well, this is made up of 1, 2, 3, 4, 5, 6 triangles. Well, this also has 1, 2, 3, 4, 5, 6 sides. So the area of a polygon is really like saying the number of sides times the area of one triangle, right? So it's like little pieces. Okay, so n, as I mentioned, this is the number of sides of the shape. This is, instead of it being base, you got to think of it like, well, this is a triangle, so that would be the base, but it won't say base, it'll be a side length. So that'll be a side length. Okay, and then the h, as I just mentioned, is your apothem, or your height, right? Okay, so when you're dealing with the regular polygon, you're looking for an apothem, you're looking for the side length, and you're looking for how many sides does that shape have. Okay, so we're going to label those things in this next shape. We're not going to try and solve anything, we're just going to label it. Okay, so if we draw a triangle, right, and it would probably go to about there, okay, to make sure that they are all the same. So it's just below that. All right, so we got our side length here. We have our apothem. Actually, I'm going to make that a dotted line just so you can see it a little bit easier. Okay, so that's our apothem, and I'm just going to use a little a for that. Okay, and we have, ooh, this is something we haven't really talked about in a while. We have this angle that goes from the center. We call that a central angle, right? So that might help us if we're looking in terms of, you know, a triangle or something along those lines. I mentioned this earlier. This line right here is called the radius, where it goes from the center to a vertex. And like I said, we obviously have the other. So central angle, one thing to note about that is that it is, in fact, the same as what we talked about yesterday. To find the central angle, you take 360 degrees divided by the number of sides. Okay. All right. So that's kind of labeling those. So in this example here, we're going to draw the apothem and create a right triangle. Perfect. All right. So let's do that. Apothem somewhere down right through there. Okay, that's done. So we're going to create a right triangle. Oh, look at that. Straight down, right triangle. Perfect. Now, since this entire length is 12, that means this must be 6, right? Okay, no big deal. All right, it says find the angle measure. All right, so find the angle measure. Well, since it is a 1, 2, 3, 4, 5, a pentagon, right? That means it's got 5 sides. So we take that central angle, okay? Because you got to think, if I connected all these vertexes, what shape would it make? It would make a circle, right? I'm trying to make sure if it's truly a regular one. Yeah, like that. Okay, so I must not have drawn my circle correctly because it should match up. So if you look, to go from the center out to a vertex, that's the radius. Okay, so either way, you know that it's a circle. And inside that circle, we have this central angle. So that means this is 360 degrees, and this is just a piece of that. Well, if it has 5 pieces, we can say 360 divided by 5 gives us our central angle, which is 72 degrees. And then to find this angle, well, that's half of that. So this would be 36 degrees, right? Okay, so 72 divided by 2 is 36. All right, so now we get our good old-fashioned trigonometry, and that'll help us find our apothem, which allows us to use our area formula. So we need x here. Okay, we got 36 degrees. We just did some calculations. So opposite of 36 is this 6, and this would be adjacent, so that's going to be tangent, right? We're going to use tangent for this one. Remember trig being SOHCAHTOA. Opposite and adjacent is tangent. So tangent of 36 degrees equals the opposite, which in this case was 6 over x, okay, or the apothem. All right, put that over top of 1, cross multiply, you get x times tangent of 36 equals 6. Well, we want x to be by itself, so you got to divide by tangent of 36. So this is x equals 6 divided by tangent of 36, which is, in your calculator, this is roughly 0.73. So 6 divided by 0.73 when you round, which gives you 8.21. Okay? And again, you can use decimals for that. You can use a regular calculator, whatever your preference is. All right, so that gives us our apothem, 8.21. So how do you find the area of any polygon? You take the number of sides. In this case, it was 5. You multiply it times 1/2 base times height. Well, base was the side length, which we knew it to be 12. And the height is the apothem, which we just found, which is 8.21. So when you plug that all into your calculator, the area of this shape is 246.3. Okay, so you might have to use some trig to find the apothem. In fact, you're probably going to have to more times than not. I told you this stuff wasn't going away. All right, so I'm going to go through the first 2 practice problems with you. So those that watch this video are going to have a little bit of a head start, which is fantastic. And then you'll complete the rest on your own and get some easy points, okay? So find the area of the regular hexagon below. Note 10 is the length of the radius. So we need the side length and we need that. Well, first, let's find this angle right here, right? Okay, and remember, it's going to be half of it. So let's see, 360 degrees divided by 1, 2, 3, 4, 5, 6 gives you 60 degrees. So that means this whole thing would be 60. So that means this is only 30. Okay, so that's 30 degrees. All right, so we need both the apothem and we need the opposite here. Okay. All right, so let's go ahead and find the opposite first. And let's see, that would be 30 degrees. Ooh, you could use special right triangles because this would be a 30, 60, 90, but that's okay. We'll just use trig. All right, so to get the opposite, that would be sine, right? Opposite, so, S-O-H. So opposite over hypotenuse, sine of 30 degrees equals, we'll just say, well, opposite over 10, which is the hypotenuse. So cross multiply gives you 10 times sine of 30 equals the opposite, which in this case actually would be 5. Okay, so let's go ahead and change that out. We'll say that that is now 5. All right, when you multiply that in your calculator. So we have 5, 10, and then we have x. Okay, well, if you have two side lengths and they're nice and whole numbers like this, let's just go ahead and use Pythag. Okay, so x squared plus 25 equals 100. X squared equals 75 when you subtract 25 from both sides. So that means x is the square root of 75, which is not a nice number, but I don't really care about radicals right now. We just want to know what is the actual area. So we're going to round this. When you do the square root of 75, it comes to about 8.66. Okay, so that's our apothem right there. All right, so area, number of sides, in this case it's a 6-sided shape, times 1/2 times the side length. Side length here is 5, so if you double that, that gives you 10. And then you have times 8.66. All right, so again, put that in your calculator, and you should get 259.8. There's your area for that one. Okay, so find your side length, find your apothem, and you're in business. All right, let's try another one here. It says find the perimeter this time of an equilateral triangle. So equilateral meaning all sides are the same. In this case, 4 is the apothem, right? Well, if this is the center and the apothem, which makes sense actually, because if you look at these triangles, they do kind of look the same. So we need to find, this base. Well, if we have that this is 4, if we can figure out this angle, then we can use trig to find what x is and then just double it. All right, so it's a 3-sided shape, so 360 divided by 3 is 120. 120 divided by 2 is 60 degrees. So that means this angle right here is 60. Okay, well, if we're looking at this angle, let me see if I can. So this would be the right angle. That means that's the hypotenuse. We don't need the hypotenuse in this case, and we already have a side, so we're going to use tangent, right? Tangent of 60 degrees. Oh, not, 60 equals the opposite of that. So opposite being x over 4, adjacent. Okay, cross multiply gives you 4 times tangent of 60, which means x is about 6.93 when you put in your calculator. Okay. All right, and again, I'll show you actually real quick just to how to put that in there. I feel like I've been moving along pretty quickly. So again, pause the video if you need to, go back, do what you need to do. But 4 times, hit functions, tangent of 63. Now notice I'll get a decimal. That's because if you go up to your settings, I have not changed it to degrees in the bottom. Now if you look, oh, I said 63. I'm sorry, I'm at 60. If you look, you'll see 6.928, which rounds to 6.93. Okay. All right, so then that gives us our x value, which is 6.93. So I'm going to double that. Okay, 6.93 times 2 gives me 13.86. So the perimeter, if this whole thing is 13.86, okay, well then that one's got to be it, and that one's got to be it because it's an equilateral triangle. So the perimeter is just adding up all the sides. We're not finding the area here. So since there are 3 sides, I'm going to say 3 times one of the side lengths, which we just figured out is 13.86. So my perimeter is 41 crap, I can't remember what it is. 13.86 times 3, 41.58. Okay? So that's the perimeter of that shape. So that's how you do the first two. I'm going to let you try the rest. I'll post the answer key with just the answers, but then you got to obviously find it from there. Let me know if you guys have any questions.